Hi, this is part 6 of this training video series, and we're going to talk about the software called VZMOD and its design and operation, how to run it. So you have seen this picture before. Essentially, VZMOD simulating the flow and the transport in this video zone is between the dream field and the water table. So the software called is called VZMOD, stands for Vadose Zone MODel. And so this is the website. You can download VZMOD, but be careful here. The VZMOD available on the website has been outdated. It's not compatible with the latest version of ArcGIS, so please do not download VZMOD from this website. And the latest version of VZMOD is already included in the ArcNLET download file, and you have seen that you can copy. There's a folder called VZMOD. You can copy it and place it into the folder of ArcNLET. But from this website, you can still download the user manual. It's still valid for the current design of VZMOD, with a little bit adjustment or upgrading. And in this website, there are two sample data sets. One is for Julington Creek, the other is for Eglinton Heights. Those are two neighborhoods in the city of Jacksonville. So unfortunately, the I just tried this morning. The data set for Julington Creek is not working. I don't know why. It's just like you buy a car, you have to maintain it. We have not maintained it for a while, so this data set is not working. But I prepared another data set. It's called for the Eglinton Heights neighborhood, and this one is working. So I will use this data set for the demo of the software run. And here's the development history. So we developed this software based by following the conceptual model. It's called a STUMOD. It's called a soil treatment unit model, developed by Gisa in 2004, or published by him in 2004. It's actually by the research group of John McRae. We just thank those people for developing STUMOD, and so that we can follow their conceptual model for our development of VZMOD. And VZMOD was written in Python because at the time of the development, which is about 2013, 2012, 2013, and ArcGIS started supporting Python programming language for ArcGIS extension development. So Python is a programming language, and it's a free software. You don't need to buy it. And the Python is also built in ArcGIS. So if you already have a GIS, Python should be there, and you don't need to download and install it separately. And for more information of VZMOD, you can read it at a paper published by Wang et al., which she was my sorry, there was a typo here. Wang et al., and she was my postdoc working on the development. And this paper can be downloaded directly from this website, or you can download it from the software or the project website. So when you can run VZMOD outside of GIS. You don't need to open GIS like what you did for ArcNLET, but you can certainly run it within ArcGIS. I will show you how to do it later on. And so here's the design philosophy. So all the input file of VZMOD are in the ArcGIS format, and you need to prepare them within ArcGIS. But almost all input files of VZMOD are from the input file of ArcNLET. So it just one stone for two birds. So you can just use the same file you prepared or generated by ArcNLET for VZMOD simulation. And all the output file of VZMOD are also in ArcGIS format. If you want to process it, for example, you want to see the results, you can process them within ArcGIS. And the output file of VZMOD can be used directly for ArcNLET. I will show that later on for you. And so here is the VZMOD. There are two ways to run VZMOD. So one is from ArcGIS, from ArcNLET. So here you can go to transport and click to start VZMOD. You see this window pop up, or you can run it directly from the VZMOD module. So here, when you install ArcGIS, you copy the whole folder of VZMOD to ArcNLET folder, and you can open the folder and run VZMOD pyw. And so here is the same window you saw a moment ago. So because they refer to the same file to run it. So from now on, I will run VZMOD for you. And the VZMOD has a number of functionality. So I will explain one by one for you. And so the first functionality of VZMOD is just to run for one septic tank. It's just for purpose of running or testing. If you run multiple septic tank, you certainly can do it. I will show you later on. To run this, I will show how to run it first. Oh, well, I will explain this first. So what you need to do to run VZMOD is there are two things. One is to determine the soil type. That's a type of soil between drain field and water table. And what soil type? The soil type is actually, this is from soil physics. This is the diagram of the soil types defined by the USDA, U.S. Department of Agriculture. Essentially, it based on the percentage of sand, silt, and clay from coarse to fine material, and then based on the percentage you can define the soil type. For example, if you are running for, say, sand, that would be 90% of the soil are sand, and 10% of the soil is clay, and also probably less than 10% for silt. So that's you have to have some soil physics background to know the definition of soil type. And also you need to specify an output folder of VZMOD. I'll show that later on. And so I will run it for you first. So here is the menu, or the windows for running VZMOD. So here's the soil type. So you have to know the soil type, and then you select the one. Say I select sand for my soil type. And then you see here we have the so-called hydraulic parameters, and those are from the Van Nopten model. I will talk about this in the next training video. But you may notice that if I choose different soil type, and those parameter values change correspondingly. So this should say if you have a soil type, different soil type, you have different parameters. And for running this model, let's say I choose sand, and then you can keep everything as is, because this is for demonstration only. I will explain the meaning of all the parameters in my next video. So after you choose the soil type, you need to choose the name of the output folder. So here where the folder name is. So be careful here. We use a fixed name for output. For example, after running this, the output file will be result.txt. So we didn't give you the flexibility to choose the name of your favorite. We just call the same name for whatever simulation. And then if you so here you specify the name of the folder, not name of file. So I just say browse it, and so here I made a folder. Let me show it to you. I made a folder. Let's see. Okay, here. So I made a folder called ArcNLET height. So here is the folder, the file you can download from the software website, and I will show you the file. I have it here. So here I have okay, accent height. So after you download it, you have this. Actually, let me go the folder. So I keep it in a, well, you can put the folder anywhere you want. I just put it here. So it has an input file. So those are all the input file you will need to learn how to run the software. And here's the output folder. Those are output file we generated for you. Essentially, there are only two output files. One is a text file. It's called result. I can open for you. So this shows the output of the depths and ammonium and nitrate concentration. But we change it a little bit later on, so the file is not exactly the same, but essentially the whole structure is there. And the other file is septic tank. So those are, you have a septic tank file, and then the VZMOD is going to calculate ammonium nitrate concentration at water table, and then write the information into the septic tank file you prepared. So for the purpose of running it, I will just generate a new folder. I will call it output test, just so that I will not mess up with the file, because once I start running it, all my output file will be written in this folder. If you don't create a new folder, they're gonna mess up the original file. So now let's go back to VZMOD. So I will pick this folder called output test, and then I'm done. Then I will click this button run. You see here it run the simulation. Essentially it output the depths from the drain field up to water table. So here is a 150 centimeter. This is the default unit, and we didn't give you flexibility to choose a unit. So we just say whenever you use the length unit, use centimeter, because that's what people use for soil. And this 150 is the same as this depth to water table. We're going to talk about this variable later on, but it simulates essentially ammonium and nitrate concentration from depths of 0 from drain field to depths of 150 centimeter that you specify here. If you change it to say to 300, this will change to 300 accordingly. And after we're done, it generates a file in the folder I just created. It's called result.txt, and let me open it from here. So this one opens the depths and the concentration of ammonium and the concentration of nitrate. So here we have a little bit more. After we develop it, we have more output. So this one is moisture content. Moisture content is essentially how much water in the pore space. Say if it's full of water, the moisture content would be the porosity. If it's unsaturated, the moisture content will be smaller than the porosity. And we have this amount of nitrification, amount of denitrification. We're going to talk about that in the next training video, what those are. And then the VZMOD also has the capability of visualizing results. So here is, you click this button, and this window pop out and say you can choose a septic tank that you want to see. Here there's only one septic tank, so the FID is automatically 0. So we say okay. So here we see two plots. This plot is actually most meaningful or useful to you. This is a profile of the concentration of ammonium, which is in green, and the profile of nitrate concentration in red. So here we had this initial concentration. This is called effluent concentration. That means the concentration of ammonium and nitrate in the effluent from the drain field. And we have these two values from literature, and their units is centimeter per liter. I'm sorry, milligram per liter. We use it consistently between VZMOD and ArcNLET. Again, is a milligram per liter. So you can see here at the drain field is 60 and 1, and during the transport process, ammonium become less and less because ammonium become nitrate. That's why the ammonium concentration decrease and the nitrate concentration increase. And you can tell that at about 6 centimeter beneath the drain field, all ammonium is gone because of nitrification, and you have a high concentration of nitrate. And nitrate concentration doesn't change much or it doesn't change at all until at these steps. So I will, and then decrease. I will explain to you later on why this decrease. There are physical meaning behind it, but for running purpose, you just see it. This is just this. We have VZMOD has this function for visualization, and those show the profile of water content, how it change from dream field to water table. And oh, by the way, this is that DTW is a depth to water table between the dream field and the water table. And this is amount of blue is amount of nitrification. I'm sorry, red is amount of nitrification, and green is amount of denitrification. So we're gonna talk about this later on. But this is essentially the first thing you run. You run it for a single file. So here you need to determine the file type. You need to specify the output folder, whichever you want, wherever you want to save the file, and the unit are fixed. And you can find the unit. There's a table in the menu. It's in page 3-4 in table 3-1, and that table lists the units of all the variables used in the VZMOD simulation. And again, the default length unit is centimeter, volume unit is milligram, and the concentration unit is milligram per liter. And so the name, this is the name of the output file folder. So there is the file name. File names are fixed for this case, and so this is the first functionality to run for one septic tank only. And yeah, I talk about this check results just for visualizing the concentration profiles and 3 other variables. And the next function is to run for multiple septic tanks. And so here I will show you. Not here. Oh, I just right here. Oh, here. Sorry. So if you want to run VZMOD for multiple septic tanks, so you have a neighborhood has a 200 septic tanks, and then you click this button. It's called a multiple source, and then after you select this item, you see this file window just is just file folder is activated. So because you have multiple septic tanks, you need to input a septic tank file, and this is a septic tank file that you already prepared for ArcNLET. You probably have already watched the video of ArcNLET. That's exactly the same file. You don't need to prepare another file for the simulation. So here I will browse. This is a we need to specify the file. So here I open it, and so this is input, and this file name is called okay, so it's a shapefile which is called export output 2, and this is a little bit weird name, but this is a shapefile for septic tank location. So you don't need to open it in ArcGIS. You just tell VZMOD where is it, and then there are command lines behind VZMOD to read this file. So you just select OK, and you're gonna run. So I'm gonna run it. You see, read parameter from GUI, which is here. Read all the parameters from this GUI, and you're gonna run. Okay, so we're done here. So let me explain to you what is modeling here. So we have here. Let me put this way. So we have here multiple septic tanks from 1 to n, but the soil type between dream field and water table is only one. So there is only one soil type, and in addition, the hydraulic connectivity and the porosity are homogeneous. Homogeneous means they are the same for each septic tank, so there's no difference. And also the distance between dream field and water table is also the same. So essentially, although you have many septic tanks, but they are all run under one condition. So essentially, the output of each file, or the output, which is a concentration of ammonium and nitrate, are exactly the same for each septic tank. So this is not very useful from theoretical perspective, but if you want use VZMOD results for ArcNLET simulation, you will need to run it so that the ammonium and the concentration at water table will be generated for each septic tank. So this is, let's see, here we have this output test, and you can see it's right here. So after I run in the previous run, it only generate result.txt, but now you have this septic tank. So essentially what the software did is it opened the septic tank file and run the simulation, and then write the simulated ammonium and nitrate concentration into this septic tank file. So I can show you what this means. So I will open it from the from the ArcGIS, and I can show you what the file, what's the attribute table of the file look like. It's gonna take a while because again I have so many things open and my ArcGIS is a little bit slow. So here is a septic tank file generated by VZMOD. So I will just open it, and so those are location of septic tanks, and I will open the attribute table. And from this attribute table, you don't need to worry about what those are. Those are information of septic tank, but those are two most important things. Now you can see in the previous example of ArcNLET run, there is only one column. It's called N0CONC, the concentration of nitrate. So, but here there's an extra column. It's called NH4CONC. That's ammonium concentration. Of course, because the soil type is a 1 and everything is homogeneous, so the concentration are exactly the same for each septic tank. That's what we're expecting. But it's running, and you can use this file directly for VZMOD. So what it does, let me show you right now. So if you open a ArcNLET, have the transport here, and then you can specify and now you can simulate both ammonium and nitrate. But here for the septic tank, you can right here. So you can specify septic tank, and now you can tell that the concentration, the source plane concentration of nitrate and ammonium are read from this septic tank file automatically, and that's why you see -1 and the yellow block here. So that means from now on you can use VZMOD for your ArcNLET simulation to simulate both nitrate and ammonium. So this is essentially the link between ArcNLET and VZMOD. Okay, so I will turn this off to avoid any trouble. So I will remove from ArcGIS. Now let's go back to VZMOD again. So this is the second functionality of ArcNLET to simulate multiple septic tanks, but with only one soil type, with homogeneous hydroconductivity and porosity. So I'll explain here a little bit. So although we have only one septic tank, but we could have different values of hydraulic conductivity and porosity at different locations. Although they belong same soil type, but those values could change. So that leads to the next functionality of VZMOD. Again, it's a multiple septic tank, only one soil type, but within this soil type, you can have heterogeneous hydraulic conductivity and porosity. That means different value of hydraulic conductivity and porosity beneath different septic tanks, and that means the flow would be different, and then everything would be different. But here we still assume that the distance between drain field and the water table is a constant, so there's no change of that. Let's see how to run it in the software. I will turn off this window and just run it. So here if you want to run multiple septic tanks with one soil type but heterogeneous hydraulic conductivity and porosity, you click this button, and two more windows are activated, and then you can input hydraulic conductivity and porosity. And those two raster files are again those you prepared for ArcNLET. You don't need to spend extra effort to prepare those files. And so I will select them. And so hydraulic conductivity is here. Conductivity is an image file, and then porosity is here. Porosity is an image file, and then I will save everything in the same folder, and then I will run it. So again, so here we're running the software for each septic tank a time, right? So you start from septic 1 and run it for each septic tank to septic tank 286. So this is a neighborhood with 286 septic tank, and then essentially you're done. And you can also see the results. For example, so here you have multiple septic tank, so you can choose, say, number 1, which has index ID is 0. So here what it look like. So you see here for this septic tank, things a little bit crazy. So ammonium quickly nitrified into nitrate and become 0 at a very small distance between from drain field, and then because ammonium becomes to nitrate, and nitrate concentration increase sharply in the short distance, right? So if you say I want to see another septic tank, so I'll say for how about 100, and then you see things different. See here, this ammonium gradually nitrified, and so nitrate concentration increase gradually. So the reason of this the reason of this two figure is that different septic tanks have a different hydraulic conductivity and porosity. Therefore, they have a different flow condition. That means different moisture content profile in the vertical direction, and then that's gonna affect the rate of how fast ammonium become nitrate. Right. So this is done, and the next function is to calculate the depths to water table. So what does that mean? So here I go back to the presentation. So in this figure shows what it means for different depths between drain field and water table. Let's say you have a drain field, and for each septic tank, the elevation of the drain field are different because you have your topography is not horizontal, and also your water table could also vary in space, and so the distance between drain field and the water table varies for different septic tanks. Then the question is, how are you going to determine the distance between drain field and water table? So we explained this in page 3-5 of the VZMOD module, but I will explain in detail here. So overall, the question is, how are we going to determine the distance between drain field and water table? So for each septic tank, so we do it for each septic tank, and so you can tell that this distance, the distance would be here. Let me explain here from beginning. So here is the elevation of the land surface, and then beneath land surface you have your drain field, right? And then this is the actual water table, but we don't know where is it. But we have this smooth DM, and I explained in previous video that the smooth DM is expected to have the same shape of water table. You can tell those are pretty much similar to each other. And then the distance between the smooth DM and the water table is A, and the distance between land elevation and drain field is B. So then we can use this 4 information or this 4 data to calculate the distance between drain field and water table. So this distance would be equal to DM minus B, and then we got the drain field, and then minus this distance, right? The that would be the smooth DM minus the A, right? So dream field minus water table. So we expect that the smooth DM minus A give us the elevation of the actual water table, right? So you manipulate a little bit, you will have the distance between dream field and water table is the DM minus smooth DM and plus this A minus B, right? And so we already got the DM, which is input to ArcNLET. We already got the smooth DM, which is it's not output in ArcNLET, but I will show you later on how you're gonna get that one from the ArcNLET simulation. But say we already have it. Let's just assume we already have it. And those are two. This is input to ArcNLET, and this is output of the groundwater flow module of ArcNLET. And then B and A, those are two important terms here. And see how we're going to do it. So here we have our B and A. So B, you can find B from manual of the Dreamfield construction. So we follow the EPA manual, and that means we choose B as 18-inch. That means the Dreamfield has a thickness of 12 inch itself has a thickness of 12 inch, and it covered by 6 inch of soil. That then we have this 8 inch between land elevation and the dream field, the bottom of the dream field, of course. And then what's the A here? To estimate A, you require you to do a so-called model calibration. That means you have the measured water table, water level, and then you have a smooth DM. And you do a regression, and you would expect the slope is close to 1, and then you have a intercept. This intercept is the distance between smooth DM and water table. So this requires you to have data and you do model calibration. We're going to talk about that in another training video. But if you don't have data, you would have to have your best guess. So for this case, the intercept is about 2.86 meter. So that means the distance between smooth DM and water table is about 2.86 meter. Right. So with this one, let's go back to the code, to the model. So we're gonna select this calculate depth water table button. So we select it. So now you see here, we need to input a DM, right? And we need to input smooth DM. And here you may notice there's a change here. So before you select it, this is called the depth to water table. You just give the value itself based on your best information or best your knowledge. But once you click it, this DTW becomes distance. This distance is actually, let's go back to the presentation. This distance is actually A minus B here. You just get your A, get your B, and you calculate the difference, and then you put right here, right? Let's run it. I will choose the distance. Let's see what the best value to use. I don't have a very good number. Let's put it like a 1 meter. How about that? 100 centimeter. And then the DM, we already have it. And this DM is this is from LiDAR data with a 5-meter resolution. It's a raster file. And smooth DM, I will show you later on how to get it. But let's say we already have it here. So this is the smooth DM right here. Then I have that. Right. So and I save everything in the same output folder, and then I can run it. Okay. Again, it runs for each septic tank. And so here I have all the files saved, and it's out here. So this is the file I just generated a moment ago. Let's look at it from ArcGIS. See, I open it from ArcGIS. Again, you saw this before, and open the attribute table. Go to the last 2 column, and you can now see that the values are a little bit different, right? So it used to be constant for every septic tank, say nitrate, ammonium, but now they have variation, right? So it varies, not sometimes substantially, sometimes not that much. This all depends on the condition you have, but those are just for illustration. You don't need to worry too much about it. Let me close this one. So this is what you see. And then you can also view your results using this check results button. You see, again, this is first septic tank. Still look this way, and you can choose like 100 and see if any difference. Yeah, so look at this. This is a little bit different. Now you see here, in previous simulation, this was 150 because that's the distance we specified. But now it becomes not 150 anymore. So this is become 300 centimeter, which is 3 meter between drain field and water table. And if you go back to 0, that's first septic tank. And so the distance is very different. It's just about maybe 25 centimeter. So this is what the VZMOD does. And here we have multiple soil type. Let me explain to you what that means. So here, in all our previous simulation, we assumed a one soil type for all septic tanks, right? And for each soil type, the hydraulic conductivity and the porosity can be heterogeneous. But there may be a situation that there are more than one soil type beneath the septic tanks. Remember, we have a total of 12 soil types. So if your neighborhood is relatively large and have a different soil type, and you may have multiple soil types here. All right, and then for that case, we can come back to here and select multiple soil type, and then you would need to input data of soil type. You need to prepare this outside of ArcGIS, but this one you have to prepare separately because we don't use this one for ArcNLET. This is an extra file you need to prepare for VZMOD. But unfortunately, I don't have this file on my computer. I emailed my postdoc who developed it and prepared this file. I've asked her if she still has it, and the reason is that the computer we used before just crashed. We reinstall it, but we forgot copying our file out. This is just like you have a car and you didn't maintain it well, and it's give you some trouble, so you have to bring it to the mechanics to fix it. Same story. It's a little bit embarrassing, but we just sort of lack of maintenance of this. And so this is for multiple soil types, different soil types. And so I will close this video by using this flowchart, and this is in the VZMOD menu, and this shows you how things run. Let's start from the beginning. So you open the VZMOD GUI, and you input all the parameters from the GUI, and then you tell VZMOD how many septic tank you have. Say if there's only one septic tank, not multiple, it go this way, and you will run a flow model and run a transport model for this is for 1D vertical flow. This is for 1D transport of ammonium and nitrate, and then there is no more source to process. Then you're gonna write everything to the text file, txt file, and then you're done. And but if you have multiple septic tanks, then you come here and you ask, do you need to calculate the distance between drain field from drain field to water table? If it's no, and then you ask whether you're gonna consider heterogeneous hydraulic conductivity and porosity. If it's no, it's just like what we did here. Everything is homogeneous. You run it, and only one file generated. But if it's if your case has heterogeneous hydraulic conductivity and porosity, you need to tell the location of septic tank and the raster file of hydraulic conductivity and the porosity, and then you're gonna calculate the flow, and then gonna calculate the just call it water retention parameter, and then you're gonna run the simulation, and then you're done. And then if you say I want to calculate the distance between dream field and to water table, because I believe it varies in space, and then you need input source location, which is for septic tank, and DM raster and smooth DM, right? And here you would need calibration to finish this calculation, and then essentially you're done. So this video, this is a summary. We talk about what VZMOD is, and multiple functions that VZMOD has, and how to run them. I give you a demo, although it's not a perfect one. And then in the part 7, I will talk about the theories, essentially conceptual, mathematical, and computational model behind VZMOD, so that you will understand the software better, and then you can use it for your real case application. And we'll see you in part 7 of this training video.